Hey everyone, welcome back to the channel. This is Expert Funda and you're watching on YouTube. So in this FAANG interview preparation series, we are going to understand the next question is LRU Cache problem. Okay, so this problem is from Leetcode 146 and you can go through the problem statement and then we'll come back to here. Okay, so this is Leetcode, right? And we know that this is problem number 146 and we are going to talk about it. Okay, so what you can do, just pause this video and go through the statement so you will understand clearly what we are going to do here. So the question is saying that design a data structure that follows the constraints of a list recently used LRU cache. Okay, and we have to implement this class, right? The LRU cache class we have to implement, in which we need a constructor that is called LRU Cache, and it will take the capacity and we have to initialize the LRU cache with the positive size capacitor, right? So the capacity is in the positive size and we have to pass in this cache so that it will get initialized, the object will get initialized, right? Further, we have to implement two more methods, that get and the put method we have to make, right? Where get method will return the value of the key if the key exists, otherwise return -1. The put method will take key and value pair, where we have to update the value of the key if the key exists, right? Otherwise add the key value pair to the cache. If it is not available, add it here, otherwise update it. If the number of key exceeds the capacity from these operations, right, evict the list recently used key. Gotcha? And then what is saying, if the number of keys exceed the capacity from this operation, the list recently used key we have to evict, right? Means we have to remove that. Then we have the function get and put, which will must run in O of 1 average time complexity. So you have to implement such a way these two methods that we are going to implement in this class should be what? O of 1 time complexity. Okay, and this is the example we have given for this problem, right? So you see we have operations. The first we have to initialize this object, then we have to use put method, again put method, and like so many, total 10 operations we have to do if you count this, and these are the value that we will put here, and so you will see the output will come like this, right? So in the first step, what we are doing here, we are initializing the constructor, as you can see, and we are getting the cache object ready, right? And then we are putting all the object here. Initially what we are doing, we are putting the element 1 and 1, so the cache will have 1 1. Next time we will add 2 2, so the cache is 1. At 1 we have 1 1 already. Now at 2 2 we are adding 2 2, right? When we'll do the get with the key 1, we know that the already value we have in the cache, so we'll return 1, right? Because the key is 1, having the value is 1, right? So we'll return here 1. Further we have 3 3, so the key was 2, right? And as you can see, the key is how many? 2 is there, right? Because we have, when we initialize this, we have passed the capacity. So only 2 key we can store, either 1 1 or 2 2. So when we have added these two, right, when we have added these push put operations, right, it means the key, the capacity will now exceed if we'll add the further. So when we are adding the key 3, so we have to remove 1 key to store the 3, and the most recently used is key 1, because we have called this function called get function. So get function will say that we have recently used this, right? Do not remove this one. The list recently used is this one, right? And so you can remove this key. So the LRU key was 2, and so we evict the key 2, means we will delete this key from there, and we will update the cache like 1 1 3 3. Further, if we'll mark, if you want to get the key is absent in the cache, right? And so it will return -1 and it will say not found. Again, when we are going to put 4 4, this time the key is 1, which is from long time we are not using, because 2 have used, 3 we have just added, but the 1 we have not used. In this case we will remove this, and so the cache will become 4433. Now when we make a get operation, you will see that it will return -1 because it's not available on the cache, right? Further, we'll make a get operation of 3 and we'll see 3 is coming. If you make the operation 4, you will get the return the 4, right? So like that, you have to represent the function, and you have to implement this data structure that is called LRU Cache class. We have to implement, and these two functions you have to operate. So as we know, this problem is very important for the perspective of interview perspective. So don't forget to write the notes for this problem. Okay, let's understand further. So now if you observe this, right, we have to design what the data structure that we have like a list recently used cache, and the requirement is we have to implement this class LRU Cache class, and we have to implement a constructor that will take capacity, and it will initialize the cache with a positive size capacity we have given, right? Further, we have a get method, right, and this get method will return the key if it is exist, otherwise return -1 if the key does not have there, and then we'll mark the key as a recently used, right? We have to mark that so that if we want to add further, so if the capacity exceed, we will return, we will not remove this one, but we'll remove that one which is not used from the long time, right? Then we'll create another method, put int key and int value. So key and value pair will be there. So if the key exists, update its value and marked as a recently used. If it doesn't exist, we'll add the key value pairs, right? And if we are adding the key, it means if the capacity exists, right, if exceed the capacity, we will delete the recently used key, right? List recently used key will remove, okay, as we have seen in the example. So the given example was this, right? And these are the constant. We know the get and put should be run in O of 1 times, and the LRU policy is what? When the policy is full, when the cache is full, we have to remove the list recently used item, the one that hasn't been accessed in the longest time, right? So these are the tame operations that we will not perform, and these are the value that we will put into this input, and so the output should come like this, as we have discussed. If you want to understand in the tabular form, just think that these are the operations, these are the steps. Means first of all, in the first step, what we need to perform, we have to add we have to initialize the list recently cache method, right? Constructor, and you will need to pass the capacity. So capacity is 2, so maximum 2 key we can add, right? So key we are not adding here because we are just initializing this object, right? So it will return nothing, right? It will return null, and so the cache state, if you see, this is, we are not adding anything because this is empty. So it initializes the cache with the capacity 2, right? Now think that we are going to add one key and its value. So key will be 1 and value will be 1. So it will not return anything because we are going to put this, right? When we are putting this, we do not do anything. Means, but now if you see, the cache state is 1. Now we have added the key is 1. If you see, we are going to add what? Another key, that is 2. So if you see, the key value pair is this, it will not return anything, but we will update the cache. Now 2 cache is there, 2 and 1. So if we talk about in this state, right, in the step 3, what is the list recently key that we have not used, right? So the 1 we have not used from the list recently used, but 2 we have used recently, right? So we'll say this is the list recently used key. So if the capacity exceeds further from this, right, means the capacity was 2, right? Here capacity was 2, and we have already added 2 and 1, right? So now we cannot add anything further in this cache because the cache state is capacity is 2. We cannot add more than 2. So when we are going to do get, you will see that we are getting 1 and the value is coming 1 2, right? Sorry, we are returning the value returning 1, right? And this is the key. So when we are getting the key 1, we will get the value 1, and the cache it will update 1 2. Understand? Further, if we'll put 3, means the cache state is already full, right? Because the capacity is already full of the cache, right? In this case, what we need to do, first of all, we will remove the list recently used from here. So which one is not used from long time? Just recently we have used 1, means 2 we have not used, right? So we will remove the 2 from here and we'll add 3. So 3 and 1 in the recently used, right? We will always add. If you observe this, we are always adding on the front, right? Why we are adding on the front, we'll talk later, right? And then we'll again do similarly. If we'll do the get operation, we'll see there is nothing is there, no cache memory is there, there is no 2 key in the cache, so we will return -1, and this is our state. If you will put 4, right, what we need to do, list recently is now what in this one, 1, right? So we'll remove the 1 and we'll add the 4. So always add the new key on the front. Similarly, if you'll do the get, right, of 1, you will return -1 because we have just removed from here, and get 3 and 4 will do, we'll get the value 3 and 4, right? So like that we have to do the action and we have to perform, and the output should be come like this. Okay, I hope you understand, right? And let's continue from here. So what is the intuition here, right? To understand the intuition, just you need to think that how you manage the recently used item in real life, right? Like you are using the tabs, or you can say on the computer when you are opening the browser, you are having multiple tabs opening in the you can say on the browser, right? And when the or you can say in the files also, right? If you're adding the files, you can see the recently used, what is the recently used in the computer, right? You can see that. So the real world analogy is, imagine you are working on a desk with a limited space, and we can say, let's suppose 2 files is there that can be open at a time, right? When you access a file, you can do either read or write, right? You will put it on the top of the desk, right? If you access an already open file, you will move it to the top. And if your desk is full, a new file is accessed and you will remove the one at the bottom. So this is called list recently used, that you make the space, right? You will remove the list recently used from the bottom. From the bottom, if you will remove and you will put somewhere and you will make the space, or you can remove it from there, right? Now what we need to do, that's exactly how an LRU cache behaves. So the cache will store key value pairs unlike a normal HashMap, and it also track the usage of the order, right? And further, the list recently used policy will, when the capacity exceeds, it will evict the key that was not used from long time, right? So I hope you understand this video, guys. You pause this video, go through the intuition, and let me know if you understand the problem statement and the intuition. Then we'll go through the coding. So there is a question that why doubly linked list we will use here, right? See, when we are going to implement the problem statement, right, you will see that we will use the linked list, and there will be a node, right? So multiple nodes are connected with each other, right? That we will see, right? And so the doubly linked list, singly linked list, I hope you will understand and you know that already. So the prerequisite is that you have at least the knowledge of linked list, how linked list behaves, right? Now think that because we can quickly remove or move the nodes in the front when a key is accessed or updated, as you have seen, right? Let's suppose give me 1 second. Okay. Let's suppose, as you see, the first we have added 1, right? And we have updated the cache, right? On the front, what we have added, so let's suppose this is a node, a type of node, right? So one node contains key and value pairs, and it should have a next node, or when we talk about the doubly linked list, it should have some previous node. Just leave it, okay? So the doubly linked list, right? I'm not talking about the cyclic linked list. It's a doubly linked list, means there will be key and value pairs, right? I want to correct. No. So now we will understand why we are using the doubly linked list, right? So the concept is, as you know, our goal is to use or to implement the list recently used cache, right? Where we need to design a data structure that will allow a get method and put method, and it should be in O of 1 times, right? So when we delete the list recently used items whenever capacity is over, right? In that case, we need a HashMap, because the get and put will come from the HashMap, right? And plus we will use doubly linked list, right? Why? Because when we use a doubly linked list, right? When we use our doubly linked list, right? So let's suppose we will use what? This plus HashMap, right? So when we'll use the HashMap, right? So the map will store what? Keys, right? And there will be some node, right? There will be keys and node will be there, right? So for O of 1 time, we need the HashMap. This HashMap we need, right? Where it will have the key and node. Understood, right? So that whenever we access the key, this key, it will give this node in O of 1 time. Easy? But it doesn't keep track of the uses of the order. Who? The HashMap, right? The HashMap will not keep track of your uses of the what? Order. When we are using, let's suppose we using 1 and 2, right? 1 and 2 in the cache, right? We just did the get operation on the key 1, right? It means the LRU in this case is 2. So whenever you want to add or you want to use this put method, right? Let's suppose we are going to add a 3, right? So which one will we have to delete? We have to delete 2, because we have just made a get of 1, right? Get 1 means 2 we have not used. So list recently used is what? 2. So we'll remove 2 from here and we'll add what? 3. So this track, right? The use of track, the HashMap will not contain. Who will contain? The doubly linked list, right? That is why I'm saying, because we can quickly remove and move nodes to the front. As you can see, if we will add now 3, in this case 3 will come on the front and 1 will go here, right? The front node for the 1 is now 3. So whenever we quickly remove or move the node to the front when a key is accessed or updated, right? Understood? That is why we will use a doubly linked list. Okay. And so with the head as the most recently used, right? That is called MRU. And tail will say least recently used. So this is the head, this is the head, and this is the tail, right? So this is your MRU and this is your LRU. I hope you understand, right? Right? Means doubly linked list, the DLL will use to keep track of uses order efficiently in O of 1 times, right? So either if you will remove, right, from here, it will take O of 1 removal. We can remove any node in a constant time with a pointer to previous and next, right? As you know, the doubly linked list, because doubly linked list will also take a node to be inserted in what? In O of 1 time. The insertion at the front that we are doing here, right? That will also be the O of 1 time it will take. So when a node is accessed, added, or move it to the front, it will take O of 1 times. Either you remove any node in this, right? Doubly linked list, it will take O of 1 times, either using previous or next. And the best thing is that it is bidirectional navigation. So we can easily remove the list recently node from the AND tail, right? We can easily remove from here, right? And then the order of uses is preserved. This order will keep preserved because head will be at the most recently used and tail will have the least recently used. So this order will be preserved. Okay. Now you will think, sir, what if we use a singly linked list? So removing the last node, right? If we will removing the last node LRU, that will take you the O of one time. O of n times, O of n times, because you need to go for all the nodes, right? If you want to remove from here, right? So it will take O of, if there is n nodes, so you will take O of n times, right? And that is, question is not saying to do that. Question is saying that you use O of n one time, not the O of n times. So no previous pointer will be here in the doubly linked list, right? So if we will use singly linked list, right? So if we are moving the nodes inside, it will be inefficient also, right? If we'll move from here to here, here to there, it will also inefficient, right? Either you are removing this least recently node or moving from here to here, right? It will also an inefficient work, right? I hope you understand, right? So what is the combined structure will be there, right? So we will use what? HashMap, that will take you can say integer and node, and the node will having key and value pair and previous and next, right? Means let's suppose if I'll take the HashMap, right? You know the HashMap, right? So we'll take integer and then there will be some node, right? You can say node, like this will take. So this will be take your integer and this will be your node, right? And this node will have, what are the things will be there? There will be key, value, we can say previous and next, right? So these elements will be there in the node. Okay. And what will be in the doubly linked list, right? Here in the doubly linked list, you can say doubly linked list will have what? The head will be there, as you can see here, right? Head will be there. Let's suppose if you have node is there, right? Node is there, right? So node 3 is there, then node 2 is there, node 1 is there, like that, right? And there is a tail. So there will be a tail and there will be a head. Understood? Head. This is bidirectional, not the single direction. You can take bidirectional. Understood, right? It will be the bidirectional. This is your tail. Understood, right? So just pause this video, go through this statement, right? And you will understand clearly. Let me remove this. Okay. So what I'm saying, we have to take O of n times for this get and put method, right? Let's go further. So what is the benefit? It will take the constant time access, correct order will be there, and efficient in deleting whenever it needed. So we have already talked about the HashMap, right? So it will take what? Integer, node, and this will be cache. Okay. Pause this video and go through this. Then we know that we will use the doubly linked list, right? You pause this video and go through this. We have already discussed. Then we know we'll take the head and tails on the front, and the front will be at the head at the most recently used and tail be on the least recently used, right? When we moving a node to the front, right, on accessing a key, get or put, make it most recently used, right? You know that, right? That we have already seen. So if we will access a key either through get or put, it will become what? Most recently used, right? And so we remove it from its current position and we'll move it to the front position. Okay. If we are deleting a node before the tail, right? The node just before the tail is the least recently used now, right? So when the cache exceeds capacity, we'll do what? Remove tail.previous and then delete its entry from the HashMap. Understand, right? What I'm trying to say, let's suppose initially the cache is having 1 and 2, right? So the key is what? 1 and 2 both are key. So if we want to move a node from the front on the axis, either using the get method or the put method, anything if you'll do. Let's suppose you do the get method, right? Now get method of, if you'll do 2, right? Now the cache will be get updated 2 and 1. Understood, right? This will be your get method will become, right? If you're doing put, if you're putting anything, right? Let's suppose now you are putting 3 and 3, right? What will be the cache? So we have already removed what? We have already updated this, right? Now we'll remove the least recently used. This is the least recently used. So it will become what? 3 and then 2. So 3 will come on the front. So it is saying if you're accessing key using the get or put, it will make it will be the most recently used. So it will be on the front, right? So move it to the front, from the current position to front position. From the current position, what? This position, it will move to here at this position. Now we are doing put method. So from here, the current position is here, it will move to here and it will come on the front, right? Like that. If we are evicting the node, right, from the tail, right, means we are deleting the node before tail, right? So how we are going to do? The node just before tail is the least recently used, right? So we'll take what? Remove tail.previous, right? So you know that here if we'll implement doubly linked list, right? What I told you, give me 1 second. I'll use this one. Okay. So when I told you head is where, let's suppose this is head. This is what? Head. Then what we will take? Node 3. Then we'll take what? Node 2. And then we'll take what? Node 1. And then there will be a tail. Understood, right? So this is head, and this is tail. So the node just before the tail is the least recently used. This node, I'm talking the one. This is your least recently used. Okay, I'm talking about this node. So when the cache exceeds the capacity, in this case, let's assume this case, it was 2 and 1, right? So when the capacity exceeds while putting the new one, right, it means we have to remove from here. So what is at the last one, least recently used? So if you consider this as a doubly linked list, means both side, it points to both side, right? In this case, this position means tail dot previous. Tail dot previous is what? This one, right? The node 1. So we have to remove from the list, doubly linked list, right? And we have to also remove from the HashMap. Understood, right? I hope you understand. So our goal is to implement this get and put method. Understood, right? And the summary is we'll use HashMap doubly linked list, dummy head and tail for the cleaner code we will use, and the combination will give us a O of 1 LRU cache. I hope you understand, right? So let's assume that first we will define a node, right? See, this node will have the key and value pair. Then this node contains previous and next node, and the node having a constructor that will take key and value pair. So whenever we'll write a node, right, we have to pass key and value pair. So each key is treating like a node. These are the necessary variables that we need to implement. So first of all, we'll take the capacity, HashMap, the key and value pair will be there, node, key and value. So value is the node that we have already seen. Node is a class that will contain key and value pairs. Then we'll have the node, head and tail. We'll take two things, head and tail, the dummy head and tail for the doubly linked list. we'll take a we have to define first the LRU Cache object, right? So this object will, when we initialize this, will need this capacity. So capacity will directly map to the capacity, and then cache will get initialized like this, and then the head and the tail we will initialize from the 0 0, means dummy head and dummy tail. Then head dot next is tail, tail dot previous is head. Understood, right? Means initially there is a cache. Okay, so let's suppose cache is initially empty, right? That we will do here, right here. Okay, now head is a node, so the head will points to here, let's suppose. So this is a head, and the head is what? Let's suppose 0. Head dot next is a tail. Here will be what? The tail, and it is also at 0, right? So we can say these two nodes we have here, head and tail, both points to the same thing. It is saying the same node, right? But if you want to observe the thing, this is the linked list, right? So head and tail we can say that. Okay, then we'll have the get method. The cache will contain the key. If it is not containing, we'll return -1, right? Otherwise the cache will, HashMap will return the value, the node, because cache is 1, there will be key, and there will be a node, right? This node will contain what? Key and value, and this is key, right? So whenever you hit this, right, let's suppose node 1, right? Whenever you hit this node key, you will get this node, right? So you will get this node here. Then you will remove this node. So there will be a method that will unlink from the current position, right? We will, so like this we have to do. So these two linking, we have to, there will be some nodes, so we will remove using this method, remove method. So these two node we will do unlinking. This linking we will break it. So when we are doing the insert to the front node, right, it means we have to reinsert the right after the head. Let's suppose we know the head will be at the most recently one, right, of the linked list. This is a linked list and this is the tail. So whenever we insert to the front node, so we will insert here, right? Any new node will be inserted this. So this node will be inserted here. When we return, means we will return the node dot value. Wherever the node value will be there, we'll return it. Okay. Now we have the put method, right? So if the cache contains this key and value pairs, right? If it contains, right, means let's suppose 3 and 3 is there. Okay, already 3 or 2 we can say, 3 or 2 we can say is already there. Again, if you are putting 2, means what? This 2 is already there, right? So now we will remove this 2 from here because we are again going to put 2 here. So we'll remove from here first of all we have to do this. Then we'll create this new node. So this 2 and 2 is a node, right? So we'll create a node like this here. Then we'll put on the cache. So when we are going to put, we'll put on the front. So head is at what? Here, and tail is at what? Here. So already we have removed the tail. So tail is empty now. So head is here, right? So what we will do now, the head and the tail is at same point, right? And so when we are adding there, so cache will get updated from 2 and the 3. Understood, right? And so we will put the cache. Okay, if the cache capacity exceeds, right? If the capacity exceed, if this is the key doesn't exist, let's suppose, okay, means let's suppose 1 and 2 is already there, right? And we are going to add 3, means we have to remove this one. So this part we have to do. We'll check the capacity is exceeding, right? So from the LRU node, which one is the LRU node? This will be your LRU node, right? So tail dot previous, where is the tail? next node, right? So this is called tail dot this one. So we'll remove this one LRU node and we'll remove the from the cache also. Okay, I hope you understand, guys, right? Let me know in the comment section that you understood and how you will remove the node, right? See, so first of all, as I told you, right, there will be head, then there will be node 3, then node 2, node 1, and then there will be tail, right, as we know. And these will be doubly linked list. Don't forget to mention this is doubly linked list. Each time we have to define. Okay, so when a node we have to remove, right? So node dot previous dot next means we have to unlink. Means let's suppose we have to remove this node. Okay, if we want to remove this node, right, then what we need to do? So node we have to unlink, we have to remove this link and we have to remove this link. Okay, and for that first we will operate this position, node dot previous dot next. So this node having a previous means what we are talking about, this, and having next, so head dot next will come what on this next on here. So this point will move, so this will be now mapped to this node, right? So we are unlinking this one. Okay, for this node what will be the, this is for the previous one that we have done. Now node dot next, so now we will remove this one. So node dot next means we are talking about this one, and this node is previous, is this, right? So of this we'll remove this one and we'll say node dot previous. Which one is the node? Means this is the node, this is a node, you can say. Okay, so node dot previous, which is the previous? This is the previous. So what we will do, we will remove this unlinking and this linking will come here. Understand, right? So we'll remove like this. I hope you understand, guys, right? So let me in the comment box that you understand. Now we have the insert to the front, the node, right? So if you, let's suppose we have the head is there, then we have node 3 is there, node 2 is there, node 1 is there, and the tail is there, right? So let me do like this, doubly link. Okay, so if we are going to add a node, where it will get added? Here, right? So the, let's suppose this is the node, right? So this node should have a next and there should be some previous, right? So node dot next means we are talking about here, what will come here, right? So we'll say head dot next, the head dot next. Node dot next is head dot next. What is the head dot next? This is the head dot next, right? So we'll add here. Okay, and now we'll say node dot previous means we are talking about this one, right? Node dot previous is what? Head. So now we will keep here. Understand, right? Then we'll do head dot next dot previous, because we have to do doubly linked list, right? Head dot next means it's next, right? Is what? Head dot next means we are talking about this position, right? This dot previous means its previous is this one. We'll put this node, means at this position who will come now? This one means this previous we are setting, for this node we are setting. And then head dot next means we are talking about this is convert node, so we will set this head. So if you talk about the fresh one, this will look like this is the node H, then node, then N3, then N2, and then N1, and then tail. Like this it will come. I hope you understand. Okay, let me know in the comment box. So thank you guys, thank you for watching this video. Let me show you in the Leetcode the full program, and you will obviously like it, this video. So let me show you the program. So first of all, in the step 1, what we need to do, as you know, we have to define the node class. So node class will take key and value pair, where we need to provide previous and next node, and this will be your node to initialize, right? Then we have to declare these necessary steps, right? Means capacity define, then cache implementation, head and tail that we need to define. Then we have to write a important function as called constructor. It will take capacity, and then we initialize this capacity, and dummy head and dummy tail we will initialize and we will put on the head.next and tail.previous will add there. Then we'll write the key to get the key, right? Get method will implement, and as I told you, will implement like this. We have already discussed, so I'll not take too much time. Then we will add the put method as we discussed. Then we'll implement the remove function and the insert to the head function, right? So that is all we have today. Let me know in the comment section that you understand the problem statement and these two important functions there that we need to implement. Okay, I hope you understand, guys. Let me know in the comment box.